Welcome back, everybody. Today we're going to get into the actual programming part of the course. Okay, we're going to make our apps actually start doing stuff. Okay, I've got kind of two lessons in one here. First thing, real quick, lesson 5, we're going to talk about the need for programming languages. And then lesson 6, we're going to get into the actual doing some programming here. Okay, so the lesson 5, need for programming languages. If we were actually in class, we'd spend a day writing instructions for things, and hopefully I'd help you try to realize that writing instructions is actually more difficult than you'd think. Okay, but I'm going to just try to explain some things quickly to you. I want to hopefully justify the existence of programming languages and then explain a few things that are different between natural languages such as English and a programming language. All right, to explain programming language then, let's look at one of my favorite quotes. I have no clue who this guy is here, but I like his quote. It is that the computer is incredibly fast, accurate, and stupid. Man is incredibly slow, inaccurate, and brilliant. Okay, the marriage of the two is a force beyond calculation. Let's talk about these. Okay, computers run fast. They can do things really quickly. Okay, they can do things accurately. All right, if a computer makes a mistake, it's actually not the computer's fault. It's the programmer's fault in most cases. But with that, I'm going to say computers are really stupid. Okay, they only do exactly what you tell them to do. Okay, what they're programmed to do. So when you hear about things such as artificial intelligence, that's artificial. It's just a computer following directions. Okay, or when a computer beats the world chess champion, it's not the computer beating that champion, it's the programmers who programmed that computer who told it exactly what to do who beat that chess champion. Okay, so computers really aren't smart. They only do exactly what you tell them to do. Okay, man, on the other hand, is incredibly slow. Okay, I'd say we don't think very fast. Compare that to some other animals who can fly through the air or run 60 miles an hour. Okay, we're inaccurate. Okay, I'm a math teacher. We make a lot of little mistakes, but at the same time, we are brilliant. All right. The creativity, the kind of things we've come up with, the programs we write are absolutely brilliant stuff. Okay, so to me, the issue with computer programming, talking to a computer, isn't that in most cases people aren't smart enough. Okay, usually it's that they're just not used to working with something so dumb as a computer, they have trouble communicating. Okay, so let's talk about the differences between a human's language, what we're used to, okay, and a programming language. Again, we are brilliant. We've come up with really complicated natural languages or human languages that allow us to communicate, crazy amounts of information, very simply. Okay, in human language, such as English, words have multiple meanings. Okay, so for example, the word cool, I could say that the ice outside is cool, okay, or this class is cool, two different meanings. Okay, there are also lots of ways of saying the same thing. I could say I'm having a bad day. I could say I'm having not a good day. I could say I'm having a terrible day. And then also different people will interpret things differently. For example, if you know me when I'm saying things to you, it might make more sense than somebody who doesn't know me. Okay, again, human language, there's multiple meanings, different ways to say different things, okay, multiple interpretations. Okay, humans, brilliant, we can handle that. A dumb computer cannot. That's why as we get into programming languages, they're designed for giving instructions. Okay, words need to have a single specific meaning, otherwise a computer can't handle it, and there's no room for multiple interpretations. Okay, so for example, when I tell a computer to set the property of something blue, it's only going to do what it tells you. It's not going to read into context. It's not going to read your mind, kind of like humans do a little bit when they're talking to each other. Okay, there's a specific thing that the computer program or programming statement will do, okay, and there's only a single interpretation. Okay, hopefully that's making sense. Lesson 5, there's 2 levels to it. On level 2, let's do this. Let's say do level 2 on lesson 5. Basically, it's just a text box that's going to take some answer from you. Let's say in one sentence, sum up the difference between a programming language and a natural language, which is what we just talked about. I want to see if you can summarize what I just said in one sentence. If you need to watch it over again, feel free to do that. Okay, but see if you can summarize the difference between a natural language and programming language in a sentence. Okay, so why don't you pause the video, go ahead and give that a try. Then you can click play. We'll get into lesson 6. All right, so for lesson 6, we're going to actually introduce you to programming. We're going to write some programs. And objectives, 2 things we're going to do. We're going to quickly talk about the difference between sequential and event-driven programs. And then we'll actually look at creating some simple event-driven programs. For the most part, the programs we write in this class will be event-driven. We'll show you the difference before we get going. Okay, first off, a little vocabulary for you. We're going to start off with programs are built up of program statements, and that's just a command or instruction for the computer to execute. Okay, so back to our computer language, we're giving computers specific instructions telling it exactly what to do. So for example, I could set the property, like I could set the big buttons text to say click me, or I could tell the computer just to say hi on the console. Okay, those are examples of simple program statements. And then an actual computer program is just a collection of program statements, and programs run or execute one command at a time. Okay, so as I string lots of these different statements together, that's how we're going to make the computer do what we want it to do. And the last bit of vocab we'll talk about is the idea of an event-driven program. That's a program designed to run code in response to specified events. Okay, so the way the program runs is going to depend on which events that the user of the program triggers. And when I say event, we're just talking about an action that causes something to happen, such as a mouse click, a button pressed, anything other kind of way we can interact with the computer. Okay, so in event-driven programs, the user triggers events, and events trigger the code to run, and the computer responds to that code. All right, so let's take a look at some programs now to actually start writing some event-driven programs. So why don't you open up code.org, okay, get into lesson 6, and as you're doing this, you're probably going to want to follow along. So if you can do kind of a split screen with this video up along with the actual programming environment, or if you have 2 different screens working, that's probably better yet, whether it's dual monitors or this could be on your phone while you're programming on your Chromebook. Okay, either way, you're going to follow along, kind of like you would in class if we were given this demonstration live. Okay, on level 1, I'm going to press continue. And let's take a look at an example of a simple program here. Okay, notice with this one here, I don't have any buttons or anything like that to press. Basically, what's going to happen is here's my coding window. When I click run, the coding statements here are going to execute. Okay, now with that, there's a couple different ways I can do my programming. Right here, I've got some blocks. We'll show you how to drag those out in a second. But if you'd rather do things text-based and just type everything in, you can click this to show the text. Okay, I'm typically going to work in the block mode just because it's easier to show you things. But I'm thinking as you go through the course, as you get more comfortable with the different commands and stuff, you'll be doing some text, and we'll show you how we can drag things into block mode as well. Okay, so for this level, do this. Let's run the program. Let's see what happens. And as this one's running, notice it's displaying things down in this debug console down here for me. Okay, most programming environments have some type of console where it's not necessarily something for the user of the program to see, but actually the kind of developer of the program to work with. And that's what's happening here. Okay, rather than displaying in the actual app, it's displaying in the debug console. If you notice what happened there as I ran this is just a step at a time. It said hi, okay, console.log, that'll be our command for actually saying something to the console. Okay, this is a simple program, and if I run that again, we'll go reset and run. It's just going to in order. Since I have my speed turned down, it's going to highlight the steps of these as I go. Okay, it's going to display each of those commands here. All right, notice a couple things. Discuss why do you think some information is in quotes and some is not. Basically, if it's in quotes, it's a string of words, whereas if I leave it out, it's going to be some type of number or variable. So difference here is this 100 printed is the number 100, not like the word 100. And then let's modify things. Okay, add 2 lines of code, one that displays a string and the one that displays a number. So to do that, what I can do is just pull another console statement over here. Okay, I can put a message. So here, what do we want to do? Is a string. Get rid of this. And then notice how I can also do the same thing in text mode. I could pull this console statement out here and it would fill in then. And then I could also put a number in, such as 77. And now when I reset and run my program, we'll see those next 2 lines. I'm going to put this back in block mode, show up at the end. I can speed my program up, make it run faster. Okay, so there's the 2 lines I wrote. If you want to play with this example some more, pause the video, feel free to do that. Otherwise, I'm going to move on to the next level. In our next example, we'll actually have some stuff happening on our user interface here. Okay, so do this, let's run the program, and we'll do that. We'll execute line by line. We have a console statement. It's like a button switch colors, got bigger, change text, followed by another console statement. Okay, so pretty simple program. Now, this one, like the last one's an example of a sequential program where when I press run, the program executes commands. There's no chance for the user to actually interact with it. We'll get into event-driven programs in the next example. Okay, but let's take a look at what's happening. We have some console statements that both happen at the beginning and the end. Okay, and then also we have something called set property here. This will be a command we use a whole lot where we'll set properties of our different user interface elements. In this case, the big button. If I reset that, I can see that this ID here is big button. And a few different things we did is we set the background color to blue. We can change the height of the button to 200. We can change the text on the button to, now it's a bigger button. And there'll be some other different types of properties we can change with these different elements here. Okay, so that's kind of talking about what is happening here. And then the last thing I want to do is modify this by adding one console log and one set property statement. Let's do the set property first. So I'm going to drag a new set property block in kind of once this first sequence is done. Now I can, like we said, type all this stuff in or drag them. I'm going to recommend dragging as we get used to things here. I want to set the property of the big button. Okay, or I suppose I could set the property of the screen. And I'm on screen 1 right now. What do we want to set on that? Let's change the background color to, looks like I've got some different options here. Let's say green. Why not? So now when I run this program, after it changes the text of the button to the now it's a bigger button, I can change the background color of the screen to green. And I'm going to speed this up just a little bit to make it go through a little faster. I can see that sequential program executing. Okay, it changed to green before end of program was printed to the console log. Okay, I also want to add a console statement to that where I can find that as kind of my variables part of the toolbox. Here's the different tools we're working with. There's a whole bunch of other commands we can use, but this will have kind of the ones we're focused on here. Before I set this screen property, let's add a console message. Let's say now it's green. We'll run that one more time here. I'm going to speed this up. We get the now it's green, before it changed to green, then the program ended. All right, so there's another example, again, of some different programming statements we can have that will run sequentially. Okay, as far as why did I do these specific things, just stuff I came to mind as I was running through here. There's a bunch of different other stuff you can do. I'd recommend pause the video, play around with some different things here. If you ever feel like you broke it and you want to get back to normal, version history, you can click start over to get back to the beginning. But yep, I'd say don't move on, don't click finish until you feel like you understand what's going on with this example here. All right, example 4, we're going to look at another program that's going to be very similar to the one we just looked at as far as programming statements go. But the difference is I'm going to say rather than a sequential program, this is going to be an event-driven program. And we'll show you what we mean. Okay, do this, run the program. Looks like a similar program, so we'll hit run. It says starting the program, ending the program. But notice with this one, none of the stuff in between happened. The switch to blue, change the height, change the text. Okay, and the reason for that is notice that this code is all within this on event block here. Okay, and that event says when the big button is clicked, this code's going to run. So in other words, that code's not going to run unless I actually click the button on the app. Okay, so this app is still running. I haven't reset it yet. When I click this button now we're going to see the switch to blue, the get bigger, and the change of text there. Okay, that's the difference between a sequential program and an event-driven program. I'm just going to move this event down here. Is the sequential part will run right away when the programs start. But if a program has event handlers, which is what this on event block is, it's going to wait till they actually do that action to run the code. Okay, so to modify it says add one command inside the on event and one command outside of it. Okay, so let's do that here. I'm going to take a set property and let's see here. I want to change my big button. Let's set the, what can we do here? Okay, hidden, so hide it. Let's set hidden to true, so in other words, it's going to disappear. So now when I click my button, it's going to change blue, 200, change the text, and then disappear on me. And let's put one other set property on the outside of our event handler. So I'm going to put it right here. Let's make the screen background color, let's say green again. And even though I'm going to place this after my on event block, okay, so we'll kind of reorder that. Even though that's after the on event block, this code's going to run before my button's clicked. Let's actually watch this run here. So in order, we got program starting, ending program, switch the screen to green. And then again, my program's going to wait. It's not going to execute any of these commands until I actually hit that button. And I suppose technically, if I never hit the button, those commands are never going to be executed on my program. So now we have the switch to blue, get bigger, the text, and then, yep, that button disappeared when I got to this switch things to hidden true. Okay, so really a nice example that shows the difference between event-driven programming and sequential programming. Again, typically we're making event-driven programs where the code we want to run is going to depend on how the user clicks buttons and how they move through that program. Okay, again, if you want to play with this some more, feel free to do that. Otherwise, when you're done, click Finish, and we'll move on to the next example. All right, example 5, we've got another simple program to work with here. I'm just going to get my debug console out of the way so I can see more of this code. And so run the program, see how it works. Let's hit run. And notice nothing happened right off the bat. One thing I want to point out is I have some comments here. Okay, in text, if I ever just go double backslash, it allows me to type some things, some comments into the program that the computer isn't actually going to do things with, but it's really a way to explain to the reader of the program what's happening here. Okay, if I want to do those in block mode under functions, I can pull a comment block out. Basically, this just explains what's happening when the user clicks the cat button, play a meow sound, and show the cat image text. Okay, and then same thing, we have some comments for the second event handler we have. All right, so it looks like we have two buttons, And I like how these are named. We have a cat button and a dog button. These commands will run when the cat button's clicked. These commands will run when the dog button's clicked. Let's see what happens here. Okay, I get a label set to cat's rule that played a sound for me, and also set the pet image to the image of, this must be the cat here. And then when I click the dog button, we get something similar. We're setting a label, it's setting the dog image. No sounds played because I don't have a sound block, I don't have a sound command statement here. Okay, and as far as how this event program works, I can go back and forth clicking these buttons, and every time I click the button, that code will run. Okay, so I can play that cat sound over and over again. It's resetting these each time, but they're staying the same. All right, so how we want to modify this, let's say add code so the dog button makes a sound as well. Okay, so let's make kind of the dog and cat equal. Controls, okay, another code block we have to work with here is play sound. So I'm going to drag that in under the set property here as well. So when the dog button's clicked, I want to play a sound. And let's choose sounds. Now something nice code.org has built in is some kind of go-to sounds here. Thinking under animals, there's probably a dog somewhere in here. I should have figured this out ahead of time. Where are we at? Where are we at? We'll go with the puppy. Choose. Now notice here I could have also done make a new sound where I could record some audio or upload a file. Okay, but we'll just go with that kind of go-to puppy one. And this false deal is going to be whether I want it to loop or not. I want the loop piece to be false, okay, so it only plays it once. So let's see what happens now. Now when I click the dog button, we get a bark along with that dog. And then what else here do we have? Change the message when each button's clicked. Okay, so let's reset. So I can set the text, the message label to something besides I don't like cats. Okay, I'm allergic to them, that's why I don't like them. I have a dog. Yeah, just something like that. So when we run things, we can watch this message here be something different. I don't like cats. I have a dog. Okay, so we can kind of work with those blocks there as well. All right, we should be good there. I'm going to move on to the kind of last example here. All right, so we have one more program that hopefully is going to allow you to see some of the different types of user interactions that can happen with these types of programs. So once again, let's make this smaller. I'm going to run this program, see how it works. Okay, and right off the bat, not within any event blocks, I have a sound being played that is looping true, so it's going to continue playing. Okay, that's just some forest sounds, so some sounds in the background. And then it looks like I have two different event handlers for the hawk and the sparrow, assuming the thing that looks like the hawk is the hawk image. Okay, and the thing that looks like the sparrow is the sparrow image. And notice that the event isn't a click, it's a mouse over. So I'm thinking here something should happen now when I click the hawk, but when I move the mouse over it. Okay, notice how things are changing here when I'm not clicking, but just every time I go over it. And what's happening here, the hawk's X property, so in other words, its X position, is getting set to a random number from 0 to 100. Same thing as Y position. And also the sparrow's moving every time I go over it. Looks like the sparrow's doing the same thing, and it's setting this message down here. You saved another sparrow. Avoid the hawk. So each time I go over there, we're getting a different sound and we're getting that message changing here. Okay, what's it asking us to do? How is this random number working? Basically, we're just picking a random number from 0 to 100, and we're setting that to the x position. Same thing, different random number for the y position. Why do you think the birds are moving even though they're not clicked? That's because we're doing this mouse over thing. Okay, so to modify this one, we want to make the birds move around the entire screen. So as far as how I could do that, once my program's not running, notice my cursor gives me the X and Y position that I'm on here. Okay, so it looks like the X from left to right is running from 0 to 320, I'm thinking. Okay, so I could say the Hawk's X goes from 0 instead of 100, but to 320, we'll say. And as far as the Y position, notice with computer screens, the Y counts down. It runs from 0 to, we could say, it looks like about 450. Okay, now when I run this program, I should randomly see my Hawk go to some different spots. Yep, so now it's way down there because we changed the Y range that it has to run. Okay, what else can we do? We can experiment with different types of events besides mouse over. So for this Hawk, we could do a click, we could do a change, key up, key down. We won't really get into those. Mouse out, mouse over, mouse up. So those would be different ways we get to click. Typically, we'll stick with the clicks. When I switch it to that, now the Hawk's not going to move when my mouse is over. It will actually move when I click on the Hawk, like so. And the Sparrow, okay, I randomly moved off the screen, is still going to move this when my mouse goes over it. Okay, there's a lot going on with this example, a lot of different stuff you can experiment or play with. Okay, I'd encourage you to do that. If you're done, click Finish. And then last thing here on level 7, it asks you about the difference between a sequential program and an event-driven program. Take a minute to think about that and see if you can summarize in a sentence or two the difference there. All right, so that's it for lesson 6. Okay, we went through levels 2 through 6. Make sure you have those completed and submitted. And again, if you want to play around with stuff on that, feel free. Okay, make sure you answer that question on level 7. Now, you don't need to be experts with any of this stuff at this point, obviously. Okay, we'll have a few days in class where we are working through this, playing with some more examples, having some specific tasks to kind of take care of. Okay, so we'll get this stuff figured out as we go. See you folks later.